Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good afternoon to everyone. So we'll start the class with Umur Kitab Al-Fatihah. Okay, so let's continue for our next lesson, let's continue our chapter 3. So first of all, let's look to our video first.
My name is Zuhairus Nizam bin Assalamualaikum and Salam Sejahtera. My name is Zuhairus Nizam bin Madarus. Today we will continue chapter 3, motion in 2 dimensions. In this section we will cover subchapter 3.1 and 3.2. 3.1 is displacement, velocity and acceleration in 2 dimensions. And 3.2 is 2-dimensional motions. Learning outcome. First, define distance, displacement, average speed and average velocity and average acceleration. Second, to describe projectile motion, launch at different angle and height in 2 dimensions graphically. Third, to solve 2-dimensional problem by applying kinematic equation of motion with constant accelerations. Motion in 2 dimensions. By using positive or negative sign is not always sufficient to fully describe motion in more than 1 dimension. So vector can be used to more fully describe motion. And we're still interested in displacement, velocity, and acceleration. Displacement. Look at the figure. The position of an object is described by its position vector r. And the displacement of the object is defined as the change in its position delta r equal Rf minus Ri. Rf is final position and Ri is initial position. Unit of the displacement is meter. Velocity. The average velocity is the ratio of the displacement to the time interval for the displacement. V average equal to delta r over delta t. And the instantaneous velocity is the limit of the average velocity as delta t approach to 0. And the direction of the instantaneous velocity is along a line that is a tangent to the path of the particle and in direction of motion. The unit of velocity is a meter per second, m over s. Accelerations. The average acceleration is defined as the rate which velocity change. A average equal to delta v over delta t. And the instantaneous acceleration is the limit of the average acceleration as delta t approach to 0. And unit of the acceleration is meter per second square or meter m per s square. The summary of the unit for displacement is meter, average velocity and instantaneous velocity is meter per second, and average acceleration and instantaneous acceleration is a meter per second square. Where an object might accelerate. The magnitude of the velocity or the speed may change with time, and direction of the velocity may change with time even though the magnitude is constant. Both the magnitude and direction may change with time. Projectile motion. Projectile motion is motion in two dimensions, which means at any point all the quantities, velocity and displacement can be resolved into two components. That is the horizontal and vertical component. At the initial point, the component of initial velocity u or v naught can be resolved into two components. That is v naught cos theta has the horizontal component and v naught sin theta has the vertical component. Assumption of projectile motion. First, we may ignore air frictions. Second, we may ignore the rotation of the Earth. With this assumption, an object in projectile motion will follow a parabolic path. Rule of projectile motion. The x and y direction of motion are completely independent of each other. The x direction is uniform motion where ax equal to 0, and the y direction is free fall where ay equal to negative g. And the initial velocity can be broken down into its x and y component. V naught x equal V naught cos theta is a x component, and y component is V naught y equal V naught sin theta. Look at the diagram. The particle that leave the origin with a velocity of v naught, not that v change with time. However, the x component of the velocity vx remain constant in time equal to its initial velocity v naught x. Also, vy equal to 0 at the peak of trajectory. But the acceleration is always equal to the free fall acceleration, and x vertically downward. The figure shows that the projectile motion at various initial angle. Complementary value of the initial angle result in the same range. The height will be different, and the maximum range occurs at a projection angle of 45 degree. This is the summary of the projectile motion. X direction, Ax equal to 0, Vx equal V naught x equal V naught cos theta equal to constant, and x equal V naught x times t. This is the only operative equation in the x direction, since there is a uniform velocity in that directions. And in y direction, v naught y equal to v naught sine theta, and this is a free fall problem, therefore a equal to negative g. And take the positive direction as upward and uniformly accelerated motion, so the motion equation are whole. And the velocity of the projectile at any point of its motion is the vector sum of its x and y component at that point, where v equal square root vx square plus vy square, and the angle theta is the inverse tangent vy over vx. And you have to remember to be careful about the angle of quadrant. And the summary, provided air resistance is negligible, the horizontal component of the velocity remain constant. Therefore, Ax equal to 0. And the vertical component of the acceleration is equal to the free fall acceleration, therefore equal to negative g, or negative gravity. And the acceleration in the y direction is not 0 at the top of the projectile trajectory. The vertical component of the velocity Vy and the displacement in the y direction are identical to those of freely falling body, and the projectile motion can be described as a superposition of two independent motion in the x and y directions. This is the strategy to solve a problem. First, you have to select a coordinate system and sketch the path of the projectile. Include initial and final position, velocity, and acceleration. After that, resolve the initial velocity into x and y component, and then treat the horizontal and vertical motion independently. Follow the techniques for solving problem with constant velocity to analyze the horizontal motion of the projectile, and follow the technique for solving problem with a constant acceleration to analyze the vertical motion of the projectile. Some variation of projectile motion. An object may be fired horizontally, and the initial velocity is all in the x direction, v naught equal to vx and vy equal to 0. After that, all the general rule of projectile motions apply. Look at example 3.2 in your textbook. Stranded Explorer. The goal of this example is to solve a two-dimensional projectile motion problem in which an object has an initial horizontally velocity. The problem: a rescue plane dropped a package of emergency rations to hikers stranded in the Australian outback as shown in figure. The plane is traveling horizontally at 40 meters per second at height of 1 times 10 to the power of 2 meters above the ground. Neglect air resistance. A. Where does the package strike the ground relative to the point at which it was released? B. What are the horizontal and vertical components of velocity of package just before it hit the ground? And C. What the angle of the impacts? Okay, first find the range of package. Use the equation delta y equal y minus y naught equal v naught yt minus half gt square. And then substitute y naught equal to 0 and v naught y equal to 0 and set y equal negative 1 times 10 to the power of 2 meter. And then the final vertical position of the package relative to the A plane solve for the time. Use equation delta x equal x minus x naught equal v naught x times t. And then substitute x naught equal to 0, v naught x equal to 40 meters per second, and the time 4.52 seconds. And the answer is 181 meter. For B, find the component of the package velocity at impact. Package velocity at impact. And find the x component of velocity at the time of impacts. So Vx from equation Vx equal V naught cos theta equal 40 meter per second cos 0 equal 40 meter per second. And Vy equal V naught sin theta minus Gt equal 0 minus 980 meter per second square and time 4.52 second. So we have negative 44.3 meter per second. And C, find the angle of the impacts. Okay, and tangent theta equal Vy over Vx equal negative 44.3 meter per second over 40 meter per second. And we have negative 1.11. To find the theta, apply the inverse tangent function to both sides. Therefore, theta equal negative 1, theta equal inverse tangent negative 1.11. So we have negative 48.0 degree. For non-symmetrical projectile motion, we have to follow the general rule for the projectile motion and break the y direction into part, up and down, and symmetrical back to initial height and then the rest of the height. Look at the example 3.5 in your textbook, page 67. Example, a golf ball leaves the ground with a speed of 30 meters per second at an angle of 30 degrees above the horizontal. Calculate the horizontal and vertical component of initial velocity, the velocity at the height of 5 meters above the ground, the maximum height and the coordinate at that point, the time of flight, and the range of projectile and coordinate at that point. Solutions. Horizontal component of velocity equal 30 cos 30 degree. So we have 25.98 meter per second. And vertical component of initial velocity is 30 sine 30 degree equal to 15 meter per second. The height of 5 meter above the ground means vertical displacement Sy equal 5 meter and Sx equal to x meter. Consider the vertical and horizontal components separately to calculate the velocity at point A. So this is the diagram. Initial velocity is 30 meter per second and at height 5 meter, angle is 30 degree. To calculate the velocity in y direction by using the equation v square equal v naught square plus 2as, substitute the value v naught y is 30 sine 30 degree meter per second square plus 2 times negative 9.81 meter per second square and times 5 meter. So we have Vy square equal 126.9 meter square per second square. And then therefore Vy equal 11.26 meter per second. And then to calculate the velocity in x direction, Vx square equal 30 cos 30 degree meter per second square minus 0 because of A equal to 0 in horizontal component. Therefore, Vx equal to 25.98 meter per second. So the resultant velocity at 5 meter above the ground will be V equal square root 11.26 meter per second square plus 25.98 meter per second square. The answer is 28.32 meter per second. At maximum
Okay, so let's continue from I think that should be enough for today. So we will continue on our own. So basically, this is motion in 2 dimensions. So before this, you already learned about motion, but only in 1 dimension. So today we will learn motion, but in 2 dimensions. So let's take a look at what we should learn. Okay, so let's take a look over here. So basically, when you have motion in 2D, That means that it's all about motion in two dimension, which means it will involve x and y axis, okay, simultaneously. Okay, it will involve axis x and also axis y simultaneously. So, okay, with a reference to what we have learned last week, so I should recap. Okay, all the equations involved in motion in one dimension. So, first of all, v equals to v naught plus at. So that will be number one. Number two, v square equals to v naught square plus 2a delta x. Okay, maybe you can write down as v square equals to v naught square plus 2a delta y. Okay, we also learned about uh, x equals to x naught plus v naught t plus half at squared, or maybe y equals to y naught plus v naught t plus half at squared. Okay, these are three equations in motions in one dimension. Okay, motion in one dimensions. So regardless of one dimensions or two dimensions, one dimensions means uh, it happens during, or it happens on only one axis at one time. Okay, it only happen one axis at one time. So satu axis pada satu masa sahaja. Okay, but in motion in two dimension, we will have two, okay, axis will involve simultaneously. Okay, two axis meaning that kita ada axis X and also axis Y pada masa yang sama. Pergerakan itu berlaku. So what happened? So let's look. This is motion. For example, this is motion in two dimension, where you have ball. Okay, the ball is project. Okay, at a certain v naught. Okay, at a certain v naught. Okay, therefore, it will project at a certain angle. Let's say theta equals to 30 degrees. Okay, theta equals to 30 degrees. And of course, it will have a parabolic path like this. Okay, a parabolic path. So just imagine that the ball will encounter, okay, a certain uh, a certain placement. Okay, so that was x. Yes, so this is y, and this is axis x. Okay, axis y and axis x, meaning that as a function of time, okay, as a function of time, you can see that the ball move. Okay, and of course it make a parabolic path. Okay, parabolic, bentuk dia parabolic. Alright, what happened? Okay, so when you have v naught over here, when you have v naught over here, so this v naught means initial velocity. Okay, initial velocity, but depending on the situations, it make a theta equals to 30 degree. Meaning that dalam pergerakan initial velocity tersebut, ada theta yang 30 darjah daripada paksi x. 30 darjah pada paksi x. And please remember, okay, on our first lesson, that vector always come with the components. Maksudnya ada V0 ni ada komponen dia. Apa komponen dia? Dia akan ada, okay, V0 X dan juga V0 Y. Okay, V0 X dan V0 Y. So samalah. Bila dia dah terbang ke atas ni pun, orang ni pun akan ada. Tapi orang ni dah tak ada VX dah. Dia hanya ada V. Dia hanya ada VX dan VY. Dia dah tak ada V0 sebab V0 itu hanya pada permulaan sahaja. So samalah. Tempat lain pun sama. Orang ni ada V dia. So setiap V akan datang dengan VX dan VY. Okay. Dan bila sampai pada maximum height, okay, of course, bila akan sampai pada ketinggian yang paling tinggi, so dekat sini kita akan ada V saja pada arah itu. So V itu hanya ada VX, while VY dekat sini VY equals to 0, maximum height. Okay. Di sini dia hanya ada VX saja. V bersamaan dengan VX. V bersamaan dengan VX. Okay, maksudnya velocity pada masa itu depending saja kepada velocity yang kita calculate. Okay, there is no Vy. Okay, Vy tak ada. So, bila sampai dekat sini, kita akan dapat Vx still lagi, project ke sebelah sana. Vx, and sekarang Vy dah jadi ke bawah. Sama juga di sini, kita akan ada, okay, V, sebab apa kita boleh ada Vx tadi? Sebab ni V dia lah. Okay, V vector. Okay, this is the vector, V vector. Ini sama juga V vector. So, akan ada komponen dia, Vy dan Vx. Bila sampai ke bawah, sampai sini, kita akan ada angle. Okay, we can actually calculate the angle. So, dia akan ada Vx dengan Vy. So, dah sampai tu Vy sahaja. Okay, kalau kita tengok dekat situ, okay, perubahan yang berlaku V0x, Vx, 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 semuanya menunjukkan kepada arah yang sama, which is ke arah kanan. Tetapi kalau kita tengok Vy, okay, dia start dengan V0y ke atas, Vy ke atas, Vy ke atas, sampai ke atas ni, sampai dekat maximum height. Okay, this is maximum height, ya. Okay, sampai dekat maximum height, Vy dah jadi kosong. Lepas tu, lepas Vy kosong, terus dia jadi Vy negatif. Tengok kan? Vy dah jadi negatif, negatif, dan akhirnya Vy jadi kosong. Okay, so that will be the difference between motion in one dimension and two dimension. Okay, motion in one dimension, kita tak bother about Vy, Vx dan sebagainya. Tapi kalau kita tengok pada equation ini, equation yang tiga yang atas tadi tu, apa akan berlaku kalau kita cuba pecahkan dia kepada tiga, kepada dua. Jom kita tengok satu persatu. Let's do it one by one. Let's say if you do have V equals to V0 plus AT. So sekarang ni, awak kena ingat, bila dalam projectile, dia akan pecah kepada dua. Dia akan pecah kepada X dan Y. Okay, ini X dan ini Y. Kita pecahkan dua. So kita tengok apa yang berlaku kepada equation tersebut. Okay, cuba ikut saya. Semua kena buat. So dia akan jadi Vx equals to V0x plus AXT. T ialah time. Time tidak dikira di dalam apa-apa pun. Maksudnya dalam X ke dalam Y ke, time masih berjalan seperti biasa. Dia tidak mempengaruhi V0 ataupun A0. Okay, tapi kalau awak tengok, bila kita buat X, dia dah ada Vx equals to V0x plus AXT. Semua dah tukar jadi X. Hanya perlu tambah X saja kepada kepada setiap term itu. Okay, Vy sama juga kita buat. Vy equals to V0y plus AYT. Okay, so itu yang pertama. Yang kedua, kita cuba tengok apa akan berlaku pada equation V square equals to V0 square plus 2A delta X. What will happen to the delta X? So, dia akan berlaku. So, X dia, Y dia, kita pecahkan lagi satu. Okay. Apa yang berlaku, dia akan jadi apa? Vx square equals to V0 x square plus 2ax delta x. Okay, untuk Vy, dia tukar jadi Vy square equals to V0 y square plus 2ay delta y. Okay, semua dah jadi macam tu. Okay, dan yang ketiga, kita tengok apa akan berlaku kepada x equals to x0 plus v0 t plus half at squared. Okay, tengok dalam x dia apa, y dia apa. Apa akan berlaku? Kita akan dapat x equals to x0 plus v0 xt plus half axt squared. Y, kita dapat y equals to y0 plus v0 yt plus half ayt square. Okay. Yang biru itu ialah motion in one dimension. Okay. Dan ada lagi satu. Okay. Maksudnya daripada 3 sekarang dia dah jadi 6 equations. Okay. 6 equations dalam projectile dia jadi 6. Kenapa 6? Because macam saya cakap, motion in 2 dimensions. Okay. So this is this is all about the topics we want to learn today. So motion in 2 dimensions. So all values, okay, all equations now become 2. Okay, we'll have 2. What is in x axis and what is also in y axis. So like I used to put the value. Okay, apa yang berlaku next ialah kita kena ingat satu benda. Okay, untuk projectile, untuk motion one dimension, kena ingat satu benda. Ax is always equals to 0 and ay is always equals to negative g. So this is projectile motion. Okay. Apa yang awak tengok dekat sini ialah this is projectile. So what happened to the equations? Okay, contoh dia, Ax 0. Okay, now this one become 0. Semua Ax ni tak ada. Kosong. Kosong. And ay apa berlaku? Dia jadi negatif g. So dia akan jadi macam mana? Contoh dia yang ni jadi Vy equals to V0 y minus gt. Contoh. Okay, kalau nak biarkan dalam ay pun biar je. Okay je. Okay. Yang atas ni dia jadi apa? Dia jadi Vx equals to V0 x saja. Okay. Yang atas ni dia jadi Vx square equals to V0 x square. Yang belakang dia jadi kosong. Okay. Yang Vy square equals to V0 y square minus 2g delta y. And last, apa jadi pada ini? Yang jadi x equals to x0 plus v0 x t. Belakang jadi kosong. Dan yang ketiga, y equals to y0 plus v0 yt minus half gt squared. Okay. So semua yang color merah tu, kalau tengok color merah tu, semua ialah equation yang kita derive sendiri daripada apa yang kita belajar daripada projectile. So this is the only equation that we'll use in projectile. Ini je equation dia yang color merah. So first of all, kita obtain dulu 3 equation yang saya cakap tu. Always remember these 3 equations. Lepas tu kita kembangkan dia. We expand the equation, the equations becomes x and y. And last kali kita ax equals to 0, ay equals to negative g. Now we will have a few sets of equations. Maksudnya kita akan ada 6 equations that will responsible for you to determine the questions. Ada soalan tuan-tuan? Ada soalan tak? Tanya dulu. Okay, so far boleh faham ya? Cool. So this is projectile motion. Okay, the projectile is all about. So sebab tu kalau kamu tengok nanti, so again satu kita kena faham untuk projectile, what is V0 x? V0 x kalau kita tengok dekat atas ni, V0 x ni ialah komponen x. Okay, what is V0 x? V0 x ialah V0 cos theta. And what about V0 y? V0 y ialah V0 sin theta. So that will give a complete versions of equation that will be used in motion in 2 dimensions. Okay, so you have blue one. The blue one will be motion in 1 dimensions. And also the black tu ialah kita expand dia. Okay, kita expand dia. Jadi dalam bentuk x dengan y. Lepas tu yang the red one tu ialah equations yang kita create hasil daripada maklumat AX equals to 0, AY equals to negative G. So this is all about the projectiles. Okay, cuba tengok kepada soalan tadi. Okay, let's say okay, cuba okay, select dulu soalan ni. Okay, select dulu soalan ni dan saya akan tunjukkan macam mana dia. Dah. Okay. So let's start first. Okay. So let's say the examples. Okay. A golf ball leave the ground with a speed of, okay. Contoh a golf ball leave the ground with a speed of, okay, so this one V naught. So with the speed tu maksud dia initial velocity 30 meter per second and an angle of theta equals to 30 above the horizontal. So betul lah lukisan kita ya. Calculate A, calculate the horizontal and vertical component. Horizontal and vertical component of initial velocity. So what will be the answers? So tadi kita ada V naught equals to 30 meter per second. So horizontal bermaksud apa? Bermaksud V naught X. Okay, what is V naught X? V naught X ialah V naught cos theta. Tengok macam mana saya tulis. 30 cos 30. So jawapan dia 25.98 meter per second. Okay. And how about vertical component? Okay, vertical component ialah V naught Y. So V naught sin theta. So berapa? 30 sin 30. Jawapan dia 15 meter per second. So jawapan akhir macam ni. Okay. The next part will be the velocity at the height of 5 meters. Okay, the height of 5 meters. Apa maksud height di sini? Height ni bermaksud apa?
Tinggi.
Ras? Tinggi. Bila maksud dia tinggi, maksud dia agak-agak jarak dia dalam X atau dalam Y?
Y.
Yes. Okay, kalau height maksud dia bermaksud Y. So ini sebenarnya height ini ialah Y. Okay, so nampak tak? Bila kita mention Y, jadi dekat equation mana yang ada Y? Tengok. So, equation ni ada? Tak ada. Equation ni ada Y? Tak ada. Okay, equation ni ada X. Jadi X. Jadi Y, tapi V. Dalam ni ada juga. Ya, ada 2G delta Y. Okay, so antara tempat yang kita boleh pakai itulah dia. And of course, yang ni dengan yang ni. So, that's why bila kita dah ada equation ni, kita dah boleh keluarkan equation ni. And for your information, dalam appendix nanti, tak akan ada equation yang color merah. Equation color merah ni kamu kena derive sendiri. Sebab tu saya ajar macam mana nak derivekan equation ni. Because once you have this equation, okay, your life will be very easy. At least you prepare yourself how to deal with soalan projectile. Okay, soalan projectile mesti main dengan equations. You must derive the equations on your own. Ataupun orang faham sendiri, tak ada masalah. But you must use all the equations. So again, the velocity and the height. Dia nak minta the velocity. Maksud soalan dia, the velocity ni, maksud soalan the velocity, bukan sahaja membawa maksud velocity, dia tak cakap pun horizontal velocity ke, vertical velocity ke, tapi dia minta velocity sahaja. So bila masuk velocity, ingat, remember one thing, V is equivalent to, nampak, a square root of V square X plus Vy square. Itu sebab dia. Kenapa saya katakan sebab, let's say kalau saya tuliskan dekat sini, let's say this is your V. So dekat sini kita ada Vx dan Vy. Sebab itulah kita boleh tulis benda yang sama. Okay, so right now we need to find what is Vx and what is Vy. Yang kita ada maklumat, y equals to 5 meters sahaja. Why not? Kosong. Why not kosong? Y equals to, maksud dia dekat sini, y equals to 5, y not 0. Okay, 5 meters, y not 0. So how to deal with it? So kita kena cari what is Vx. Okay, at the speed of, at the height of 5 meters. Okay, so again, so macam mana nak dapatkan dia? So we can actually just transfer the value. So again we have Vy. So Vy dulu. Vy kita ada dua. Satu Vy equals to V naught y plus Ayt. Satu. Ataupun Vy square equals to V naught y square plus 2A delta y. So yang mana yang lebih sesuai untuk soalan ni? Adakah yang ada T ataupun tak ada T? Yang mana yang sesuai? Kenapa tak ada T?
Sebab dia tak bagi time.
Yes, sebab dalam soalan, pada tempat ketinggian 5 meters tu, there is no time. Okay, time is very important to tell the exact location, to tell about displacement, to tell about anything, kita mesti relate dengan time. But since these questions, tidak ada time pada soalan tu, pada masa tu, pada masa 5 meters tinggi tu, so kita kena gunakan equation yang kedua. Sebab ia lebih sesuai. Sebab nanti kalau awak nak cari Vy, time tak ada, tak boleh lah, ada dua kan. So therefore, from our calculations, nampak ya macam mana? Vy squared, maksud dia we can easily put this value V naught sin theta square plus with 2 A kita gantikan negatif 9.8, okay, and y equals to delta y equals to 5. Okay, that will give you Vy square. So Vy, so everything awak akan dapat 11.26 meter per second. Itu baru Vy. Selesai ke? Belum. Dia kena cari pula what is Vx. Okay, so Vx sama dengan apa? So kalau kita tengok Vx, kalau tengok equation Vx apa? Ada dua je. Satu dan satu lagi yang bawah. So Vx kita ada dua, which is Vx equals to V naught x, ataupun yang kedua Vx square equals to V naught x square. Tu je. Okay, so mana-mana dua-dua pun lebih kurang sama kan. So we can actually get the Vx. Okay, so what is V naught x? V naught x adalah V naught cos 30. V naught tadi berapa? 30 kan? 30 cos 30, jawapan dia 35.98 meter per second. So now you get Vx Okay, dah ada Vx, dah ada Vy. So masukkanlah dalam Vv equivalent to square root of 25 square plus 11. Dapatlah jawapan akhir dia 28.32 meter per second. Untuk soalan B. Panjanglah. Okay, untuk soalan C. Okay. Maximum height and the coordinate are at that point. Okay, maximum height and coordinate at that point. So, apa yang berlaku dekat maximum height? Okay. So itu sebab tu kita kena pandai tengok soalan dia. Bila dia mention maximum height, maksudnya dia nak apa? Apa yang dia nak dalam dekat maximum height? Dia nak X ke dia nak Y? Dekat maximum height.
Y.
Okay, maximum height maksudnya dia nak Y. Y equals to berapa value dia. Okay. Dan untuk apa panggil, untuk coordinates tak ada masalah lah guys. Once kita dah ada Y, kita ganti untuk dapatkan X saja. Okay, sekarang ni apa equation kita boleh gunakan untuk Y? Right? So itu saja kita kena fikir. So maybe kita boleh gunakan V square, Vy square. But since kita dah ada Vy kan, Vy square equals to okay, 2G delta Y. Okay, kita boleh gunakan. Kenapa saya kata kita boleh gunakan yang ni? Sebab pada masa maximum height, remember, okay, pada masa maximum, Vy equals to 0. Okay, Vy equals to 0. So, you can put this value. So, 0 equivalent to V naught Y. V naught Y kita dah calculate tadi kan. Berapa V naught Y? Atas kali 15. Okay, 15 square. Okay, this one is V naught Y, V naught sin theta square. Okay, tolak dengan 29.8. How about delta Y? Delta Y tu yang kita nak calculate. So from this you can get Y equals to 11.47 meters. Okay, so dapat. Sekejap saya ada orang tanya soalan. Okay, ada tanya how do we get the value for delta Y? Delta Y yang kita nak cari lah. Ada? Yang kita nak cari itulah. Maksud dia delta Y ialah Y lah. Maksud dia delta Y ni ialah actually Y minus Y naught. So Y tu yang kita nak cari sebab Y naught definitely nilai dia kosong. Dalam kes ini Y naught memang kosong. Okay, so Y tu yang kita nak cari. That's why saya buat Y tu kat situ. Okay, delta Y tu maksudnya Y tolak Y naught. Okay, and how about the coordinates? Coordinate macam mana? Berapa coordinate dia? So okay, so maybe kita boleh gunakan to calculate the X coordinate. Since Y kita dah ada 11.47, we must first calculate the time required at that point. Okay, at that point time dia berapa? Okay, to calculate time using equation, so macam mana kita nak buat? Right, so time dia pada masa tu berapa? Since Y kita dah dapat, kan? Sekarang kalau kita tengok coordinate system X dengan Y, so Y ialah yang ni lah. Okay, so this is Y. Sekarang ni kita dah tahu X. So in order untuk tahu X, kita kena calculate dia punya time. Okay, we must calculate the time first. Kenapa? Sebab kita tahu nilai X kat situ berapa. So in order to get that value, so ingat kita ada Vy equals to V naught Y minus GT. Okay, so kita boleh gantikan dekat Vy equals to 0. Maksud tu 0 equivalent to V naught Y ataupun GT equals to V naught Y. Kita dah bawa ke sana, kita bawa GT ke belah sana. So T will be equivalent to V naught Y divided by G. Okay. So 15 tolak dengan 9, bahagikan 9.8 dapat 1.53 seconds. Okay, 1.53 seconds kita masukkan ke dalam X equals to X naught plus V naught XT. Okay, so X naught will be 0 plus with V naught X. Apa V naught X tadi? 25.98 kali dengan 1.53. So dapat jawapan dia 39.72 meters. So koordinat dia ialah 39.72 dengan 11.47. Okay, last question, the time of flight. Okay, the question asks you about the time of flight. Apa maksud time of flight? Time of flight ni berapa banyak panjang masa dia berada di udara. Itu maksud dia time of flight. Okay, time of flight, macam mana kita nak calculate time of flight? Okay, so in order, tadi kita dah calculate time 1.53 seconds ini ya. 1.53 seconds ini ialah separuh. Maksud dia pada masa maksimum height. So sebenarnya kalau kita tengok kalau dalam situation ni tadi bola golf naik sini, dia jatuh sini. Okay. So kalau pada maksimum height which is tengah-tengah ni nilai dia 1.53 seconds. So kalau bila jatuh, this one will be symmetry. Okay, bila symmetry maksud dia time of flight will be 2 times 1.53 seconds. Jawapan dia lebih kurang 3.06 seconds. Betul. Okay. Ataupun kita boleh gunakan cara lain. Maybe kita boleh gunakan Y equals to Y naught plus V naught YT minus half GT squared. Okay, so we can put sini 0 equals to 0 plus dengan 15 kali dengan T tolak dengan half setengah kurungan 9.8 T square. So kena lagi panjang lah jalan kira dia, kena guna kuadratik ya. You will get T1 berapa, T2 berapa. So ambil yang positive value positive value. Get the positive value. So that's why value dia 3.06. I'm not sure whether T1 atau T2, tapi jawapan dia 3.06. The same goes to this. Okay, and the last part will be calculate the range of the projectile. Range of the projectile maksudnya apa? Okay, kalau kita tengok tadi ni bola golf sampai ni sampai hujung. Okay, range of the projectile ialah jarak ini. This is the range of the projectile. Okay, soalan last, range of the projectile. So therefore, kita nak cari apa? X atau Y? Definitely kita nak cari X. So X will be equivalent to X naught V naught XT. Okay, what is X naught? 0 plus with V naught X ialah 25.98 kali dengan apa masa tadi kita calculate 3.06. So therefore jawapan dia 79.45 meters. So that will be the range. Maksud range ialah jarak keseluruhan. Jarak daripada mana ke mana lah. So dalam kes ini soalan nombor 4 dengan soalan D dengan soalan E berkait. Maksudnya soalan D untuk cari dia punya timing. Timing, contoh dia timing dekat sini 0. Okay, timing dekat sini kita dah dapat 3.06 seconds. Okay, so timing dekat tengah-tengah ni ialah timing dia 1.53 seconds. So every time kita nak cari apa-apa pun, make sure kena cari dengan time. Carilah dekat mana-mana tempat pun. Okay, everything will be based on time. Because when you have time, you can put inside the calculations whether you want to get the horizontal displacement ataupun vertical displacement. ataupun apa-apa juga value. So make sure selalu tengok pada perkataan horizontal ataupun vertical. Horizontal means dia nak dalam X, vertical means dia nak dalam Y. Okay, dia nak dalam X atau dia nak dalam Y. Alright? So itulah maksud dia. Ada soalan? Ada soalan tak? So
No.
kita akan buat lagi kita akan buat beberapa latihan lagi, tapi dalam next class lah. So next class pun saya akan masukkan dengan chapter baru juga on Thursday ya. Okay, so I'll stop here insyaAllah. Nanti kalau ada sebarang
Ada
masalah,
soalan
kamu boleh.
soalan
Teruskan.
dia yang quiz tu kan, pada hari apa Ustaz?
Tengok soalan apa. Soalan quiz soalan hari apa tak tahu lagi. Still not sure. Lepas ni baru dapat tahu sebab lepas ni baru ada meeting within all of us. Bersatu. So masa tu baru tahu. And then afterwards bila kita dah tahu, dia orang akan upload ke dalam, dia orang akan letakkan pengumuman yang official supaya semua orang tahulah quiz tu hari apa dan pukul berapa dan sebagainya. Quiz chemistry pada time tutorial guys? Tak tahu
Tak tahu.
Okay lah. Saya tak tahu juga pasal chemistry. Tapi yang fizik baru nak tetapkan sekejap lagi. Maksudnya ada meeting pukul 1 ni baru dia orang nak tetapkan. Okay. So I think I'll stop here. InsyaAllah kalau anything regarding the problems, please please look at the videos again and again. Tolong tengok video tu. And then of course kalau ada masalah, please put in my new futures, okay, under forum, and also of course tolong do some revisions, okay. So untuk quiz yang saya boleh tahu, yang saya boleh bagi tahu, dia hanya involve tutorial 1 sahaja. Okay, chapter 1 je quiz. Okay, so you only need to study chapter 1, which means tutorial 1 lah. Okay, so thank you very much everyone. Thank you for your attention. So Assalamualaikum warahmatullahi wabarakatuh.
Salam. Thank you, sir.
Thank you,
Thank you
sir.
sir.
Thank you